Oh, I'm really delayed in the thing.
I can't see you on here. Is it possible to see you? I could just keep you up on YouTube, I suppose.
I can't. I don't think I can use my screen, my camera twice.
No worries, no worries. I'll put you up on YouTube so I can see you on the other side.
Okay, but there's going to be like a 8-second delay or something. So
yeah, it's fine.
Unless I'm holding like a freak out response, right? Anyway, so
you're good.
I think we're no, it still sounds bad on YouTube. Let me double check. Oh yeah, no, it is really bad on YouTube. It actually might be on my end. Let me video packet loss indicator of video green is good. Okay, let me just double check your audio settings. What if I'm gonna turn off your video really quick. If it's a video, like if it's that kind of issue.
Yep, gotcha.
It didn't turn it off for some reason.
They're saying the sound is better now. It's like a mixed bag of results.
Okay. Well, turn off your now it's good. So let's just go with that.
Awesome.
Your video's not up. Right. So you think the Earth is flat?
Yes. You said you asked earlier what I think the shape of the Earth is, and I wanted to present to you a null hypothesis for flat Earth, or flat versus globe.
Okay. What's the null hypothesis that you're using here?
Okay. Cool. Is it? I'm sharing my OBS cam now. You can see this?
It's very, very tiny.
I got you. Can I manually screen share on here? Is that possible? Yes, it is.
No, I don't think so.
Show entire screen. I think we're about to make it happen. Inshallah.
I don't. Yeah,
no, I can't. Nah, didn't work. Yeah, it didn't work. Rest in pieces. Okay, no worries. I'll just run you through it with the auditory version. So using the sky to prove the shape of the ground, you can't use the sky to tell you what the shape of the ground is, but you can use it to tell what the shape isn't. So using the null hypothesis format, which I'm sure you're familiar with, we're going to make our H1. Earth is planar and measurements of curvature are dependent on the positions of celestial bodies. And H0 is the Earth is planar and measurements of curvature are dependent on the positions of celestial bodies.
Okay. That's fine.
Okay. My alternative hypothesis is the Earth is globular and measurements of curvature are independent of celestial bodies. Make sense so far?
Well, sure, but that's not the globe Earth claim, right?
No, it specifically is. Do you know what the graticule is, the latitude longitude system?
I don't know what the word graticule. I don't know what graticule means. I've never heard that word before.
I got you.
By the way, we can see your thing, but it's very, very tiny, and I can't make it bigger.
Yeah, no, that's no worries. I'm just gonna walk you through the explanation.
I'm actually gonna disconnect that because otherwise we can't see your lovely face.
Oh, you know what? Yeah, you know what? I'll go back on face. No worries.
Yeah. It's just better that way.
Yep. Awesome. Okay, so let's see, where were we at? So the graticule, right? That is a spherical coordinate system that is represented by latitude and longitude. And it has a primary definitive characteristic called a fundamental plane that intersects through the center of it. You might, call it the equator. Sure. Okay. Sure. So do you know how that coordinate system was constructed?
No, I don't. I don't know the history of the latitude and longitude system, no.
Got you. Well, it's really interesting. So
is it relevant to the conversation?
No, absolutely, because this is the baseline fundamental for all maps and everything.
Well, no, but the history is irrelevant. You can test whether it's a particular shape without knowing the history, right?
What's your test?
Well, it presumably you were going to present one, so it shouldn't depend on the history.
Well, if you don't know the history, you're not going to understand what my point is, what the point of this null hypothesis is. So I understand you don't. Hold on one second.
Need to know history in order to test the hypothesis.
If you don't know how the map you're using was derived, you can't know of its correctness, right?
So that's not true at all.
Oh,
you can test whether something is correct or not without knowing where it came from.
Okay, how do you test measurements of curvature independent of celestial bodies?
You could literally do geodetic surveying, right? You could literally measure distances.
Exactly. Do you know what geodetic surveying is?
You could literally measure curves. or straight lines or whatever. You can measure distances on the surface of the Earth. You don't need to look at the sky to do that, right?
All right. If you would, please, because this is very important, because this is why I was going through the history, because geodetic surveying is super relevant to this coordinate system and how it was used to, measure the Earth, right? So what they started off with was the nautical almanac, where they had the GP positions for all of the stars, right? And they determined all of these by taking cosines to the stars and using the coordinate system itself, one of the latitude lines extending from the North Pole to the equator, which comes out to a distance of 6210. So they use that as their baseline, and then they use all units of measurement, so meters, kilometers, miles, nautical miles, all of that are fractions of the terrestrial meridian. So what they can do with that, now that they have a coordinate system and they can follow cosines to the stars if they use a capped elevation angle. So when you do that, you can use the ratio of the angle to get the distance. So when they started traversing the land to take zenith measurements of the stars, so what they would do is they would look out, they would see a star like their 45-degree angle, ratio that out, get the distance, traverse the land, go underneath the star, look up. And when they started taking zenith measurements, the star was never quite in the center of the telescope like it should be if you were completing a 90-degree triangle, right? Make sense so far?
I just don't see how it's relevant.
Well, my hypothesis, right, if we call back to that, is that the Earth is planar and measurements of curvature are dependent on the position of celestial bodies, stars, planets, moons, sun. And the alternative is that the Earth is globular and the measurements are independent of the celestial bodies. So
which one's your null hypothesis?
My null is that the Earth is planar and the measurements are dependent on the positions of celestial bodies.
Why is that the null hypothesis rather than the alternative hypothesis?
You think I should flip those around?
Probably.
So my understanding of the null hypothesis was you put the thing you think to be true and then you go over evidence to falsify it. And if you fail to falsify it, you keep the null hypothesis.
No, the null hypothesis is the thing that is, when you're trying to prove that something is true, you make that is your alternative hypothesis. The null hypothesis is just the opposite. Okay.
So vice versa, switch it then so that it's easier to digest. Now that you understand the premise, though, right? And then
given your own premise, where the null hypothesis is that the Earth is globular and the alternative hypothesis is that the Earth is planar, in that case, your own statement that you cannot prove hypothesis, you cannot say prove the shape of the Earth by looking at the sky, but you can disprove the alternative hypothesis. So even with your own description, you're not going to be able to prove the shape of the Earth, that it's planar, by looking at the sky.
You could tell what shape it isn't, though, right? That's the primary feature of this. Yes, that's why we were going over the history of geodetic surveying. That's why it's important to understand what geodetic surveying is. It is not measuring.
I don't think that you need the history in order to actually explain what's going on. It just seems irrelevant.
I would be much appreciative if you would let me get through my point instead of cutting me off midway through before you can hear it. It's not very productive.
You rambled for a few minutes about the history, which wasn't relevant for the actual experiment you're about to describe.
Nope, we're talking geodetic surveying right now, my man. You just don't know it because you don't know the history because you won't let me finish.
I don't care about the history. I care about any experiments or any observations that you can make now.
Yes, and we're going over how to interpret the measurements that we make now with geodetic surveying and how they're done. And if you don't know how they're done,
you agree that you can travel a distance?
Yes.
You can just travel a distance in a car, right? So you don't need to use the stars to do that, right?
Did you understand what I said when all units of measurement are ratios of the terrestrial meridian, which is in reference to the sky, the position of the stars?
A mile is not.
Yes.
A mile was based off of some Roman thing, I think.
All units of measurement are derived from derived as a fraction of the terrestrial meridian. Do you understand how?
That's not true. A second is related to a cesium atom.
You can use a coefficient to link the speed of light to the same thing as well for a meter.
No, that's how the second is defined. It's not in reference to the speed of light.
I'm sorry, the oscillation rate. Sorry, I was talking. They also use a coefficient for the actual speed of light to link it to the same thing to make it a meter as well. That's what I thought you were talking about.
You can make a meter and you can define a meter off the speed of light and the second. That's true.
Right. Okay. So let's
the measurement doesn't have anything to do with the celestial sphere.
Nope.
Distance of a meter in particular.
Certainly does, because they use a coefficient to link it to the fraction of the graticule. This is why
I'm sorry. Does the
yes.
speed of light have anything to do with the celestial sphere? Measuring the speed of light?
No, but when you use the coefficient
does the cesium atom have anything to do with the celestial sphere?
No, but do you understand that using a coefficient?
So then the meter has nothing to do with the celestial sphere.
Incorrect.
Well, look, the meter is defined as the speed of light, as it's defined as a particular fraction of the speed of light times 1 second, right? That's how the meter is defined. It's 1/299 millionth, whatever, of the speed of light times a second. Now the speed of light is defined, you can just measure it. It's actually kind of just defined to be 299 million whatever meters per second. A second is measured empirically using cesium atoms. So the meter has nothing to do with the stars. It's just a thing that's defined in terms of the speed of light and a second.
All right, here we go. All units of measurement, and you can look this up later on your own time, but I put a link in the YouTube chat if you're able to put that up for me. All units of measurement are linked to the terrestrial meridian, which is linked to the stars. Now,
I don't see it in the YouTube chat, by the way.
Okay. In addition to that, they use a coefficient to make the speed of light a ratio of that as well. So although it's not directly linked, and you could use the oscillation rate of cesium to define a second, I absolutely agree with that. An oscillation rate of 9,192,000,000 some oscillations a second, right? I'm on board. I'm with you,
sure.
Right? But also, that has been incorporated into the graticule. That is why there's no.
But you got the causation in the wrong direction.
Well, if we agree that they are all ratios of the terrestrial meridian, then we can proceed.
We do not.
Well, do you have an email that I can contact you at? Because I would like to send you the actual documentation of all this so that we could go over this again.
I think it's in my. I don't want to say it out loud, but I think that.
Gotcha.
Actually, yeah, it's drblitzphd@gmail.com.
Dr. Blitz.
Blitzphd@gmail.com was taken for some reason. Don't understand that, but.
Dr. Blitz PhD@gmail. Okay, I will email you some stuff, and I would love to follow up on you or follow up with you on this, because I notice a lot of people you talk to don't really know the significance of the history of all of this and how it ties together. And obviously, if you look at it through the lens of like, oh, we have geodetic surveying, it's like, okay, cool. I agree. You can take measurements, you can cosine things out, you can reference the stars to make the measurements. But what you aren't familiar with on the aspect of geodetic surveying is that it's all in reference to celestial coordinate system transformations with respect to where the ideal position of a star is based off of parallel light rays incoming.
Question.
Yes. Go ahead.
Do you think that, let's say that the Earth didn't have water on it just because it makes traveling easier, right?
Hang on one second. I would like to answer a YouTube question in the chat. So my boy Fenton Molly says, why can't he just move forward? I could move forward, but it would not be. If two people in the conversation don't have like a mutual understanding of things, then proceeding forward isn't going to make it a difference. It's not going to be gratifying for either of us to talk past each other. You know what I'm saying? So if we can't reach a fundamental understanding on the ratios of measurements, then we should focus on that and clear that up first, and then proceed forward, because I think this could be a really good conversation, but it will require some effort on your part, as there's information that you've probably never heard of. So anyway, what was your question?
Let's say that the Earth has no water on it just because it makes it easier to travel, right?
Sure.
Imagine there's no water, it's completely barren. And imagine that you were blind.
Okay. So in
principle, you could travel in a straight line, just, get in a car or, just walk. Maybe you have, it's hard to walk in a straight line when you're blind, I imagine. Maybe I don't. But anyway, in principle, you could, without having anything to do with the stars, you could just walk in a straight line for 10,000 kilometers. And then you could turn left, walk in a straight line for another 10,000 kilometers, and then turn left again and walk in a straight line for 10,000 kilometers. Now, regardless of what's going on above you, regardless of what the sky is doing, what the sun is doing, what the stars are doing, you will either end up back in the same place again, or you will not. Do you agree?
Yes.
Okay.
Sure.
Now, if you end up back in the same place, the Earth is a sphere. That's a property of a property of the intrinsic geometry of spheres, right? That in particular you can draw a triangle that has three. Right.
Agreed.
And if you don't end up back where you started, then the Earth is a plane. Well, If you end up 10,000 kilometers away, then the Earth would be a plane, right? If it was some other distance, then it might just be a larger sphere. So this is a thing that, I mean, at least in principle, could be done without any reference to the sky, right?
Nope. So, well, in theory, right, it could. But here's the thing. You would walk that, you would never know if you're off or not, and no one's ever done that. An equilateral triangle of 1 kilometer has an angular excess in it of 0.002 arc seconds. It's imperceptible, right? You can only get angular excess
sure, it's very small.
That would be noticeable.
What I'm saying is that it's not necessary.
Bro,
go ahead.
What you would only get spherical excess over these large distances like that, right? Now, nobody has ever done the walk in a straight line and make the triangle like you're suggesting. All measurements that have been done like this are done over smaller distances, and then zenith measurements of stars are referenced, and then corrections are done, right? They call them astronomical corrections, and they do astronomical transformations to line up the zenith measurements. And then you get into 2 different types of corrections to facilitate why they're off or not. One would be the deflection of the vertical due to the Earth being an ellipsoid. The other one would be due to gravitational anomalies due to the Earth being a geoid. The geoidal model is a gravitational model that intersects with the ellipsoid model to create offsets where they can say that, it might be a little flatter, rounder here because of the zenith position being off, but maybe it's still off a little more. So they say that we need to introduce a gravitational potential correction to be perpendicular to Earth's gravitational field, which they call that
there are lots of corrections. I agree. But the point is that it's at least in principle possible to measure the shape of the Earth, to do this kind of thing, and without referencing the sky at all. Right?
That was my hypothesis, and it is not possible to substantiate curvature because the curvature could be optical. You actually have to reference flat or curved in reference to an external source, and that would be the stars, my man.
Wait a minute. So I'm pretty sure you just agreed that actually, at least in principle, it is possible to do this experiment. I mean, it's obviously not practical, but it's at least in principle possible, and that has nothing to do with the stars.
Sure, but no one's ever done it, and no one's ever verified the angular excess. Well, you're prefacing a complete hypothetical.
Well, my point is that it doesn't require looking at the sky. You can learn things about the geometry intrinsically without any sort of extrinsic reference. Now, one of the ways that you can do this is you can, for example, just drive long distances, like thousands of kilometers. That's a thing that you can in principle do. If you drive through a rectangle long distances, then like thousands of kilometers, you can at least get a decent approximation. You can, and like this is the kind of thing that's been done, right?
I completely agree that when you use a unit of measurement derived from a terrestrial meridian, it will actually correspond to a place on the Earth. That's why that part of the conversation is fundamental, bro. Because your argument is my argument.
Meters derived from the terrestrial meridian? No, meters are the second times the speed of light. That's what a meter is.
Yes, but again,
299 millionth of the speed of light times a second.
Do you remember that coefficient that we were talking about that you're unaware of, and why we have a fundamental?
I'm only talking about meters.
Please don't interrupt. The fundamental impasse that we're at right now is that all units of measurement are linked to the terrestrial meridian, including the speed of light. And I will
tell me how that works.
Through a coefficient that's used. I will send you the details for it. It is
what coefficient? How do you measure the why is it required to use some sort of celestial features to measure the speed of light?
Buddy, I didn't make the coefficient. It's not what I did.
No,
right?
I'm just asking you.
It's just what was done.
Where does that come up?
What's that?
Are you talking about originally, when the speed of light was originally measured, like 300 years ago?
No, this is a modern thing.
So you can measure the speed of light using pretty rudimentary tools.
I'm aware.
Without referencing the sky at all.
I'm not contesting the speed of light, right? I'm saying there's a coefficient. Listen carefully, please.
What coefficient? Coefficient relating what?
I'm going to send it to you.
Okay. Or you could just tell me what this is a coefficient of, because coefficient is just a word. It's a term in front of some variable.
Yes, they introduced a constant to make it a ratio of the terrestrial meridian. That's what I'm telling you.
Okay.
That's what I'm trying to tell you.
What constant? What ratios?
Sending it to you now.
Or you could just tell me what the ratios, what it's a ratio of, what the constant is.
It's a ratio of the terrestrial meridian, my dude.
A ratio is a ratio is a relationship between two things. You only listed one thing.
They're linking the speed of light to the terrestrial meridian. Do you understand that part?
So the terrestrial meridian is a noun. It's not a number.
6210 is the distance that they're using. That is the length of a terrestrial meridian.
6210 what?
Man, you ain't going to interrupt me before I can say it's the length of a latitude line from the North Pole to the equator. Please don't do that anymore.
In what units?
Miles. You could use miles, you could use kilometers, you could use nautical miles. These are all the same units of measurement.
Okay.
That's
now, what does that have to do with the speed of light?
Hey man, I'm going to send you the email for everything, and we'll recontinue this, because I feel like you're having a hard time following it without having seen the math for it. And I think once you see it, we can continue the conversation.
All right. I'm awaiting the email.
All right. I appreciate your time. I'm going to head off.
Later, Gator.
Later.